Good day, everyone. We are Group 7 and we are going to be presenting our case analysis. So, starting off, we have the overview. So, this case focuses on the Automobile Alliance plant in Detroit, which manufactures two mid-sized cars, the Family Thrill Seeker and the Classic Cruiser. The problem centers on how to allocate production between these two models to maximize profit given several operational constraints. So these constraints include limited labor hours, 48,000 normally with a max of 60,000 if overtime is allowed. There is also a shared material limit of 20,000 doors on top of that. Demand is capped for the cruiser at 3,500 units, while the Thrill Seeker has no demand limit. So our goal is to figure out the most profitable combination of the two models within these limits. Okay, so moving on, we have the key facts and profit summary of what we know in the case. So in terms of profitability, each thrill seeker earns about $3,600, while each cruiser brings in $5,400. So the best scenario happens when overtime is allowed and marketing increases cruiser demand by 20%. That setup lets us produce 3,000 thrill seekers and 4,000 cruisers, leading to a maximum profit of $32.4 million. So, factoring in the extra costs for marketing and overtime, it's about $2.1 million, and we still come out ahead with a net gain of around $3.66 million compared to the base case. So overall, using overtime and boosting demand through ads is clearly the most profitable strategy.
In this model, we use 0 and 1 to indicate the demand, since it was not given. Since there is no demand for the family thrill seeker, the input is 0, while it is 1 for Classic Cruiser. The family thrill seeker would produce 3,800, while the Classic Cruiser would produce 2,400. For this, the marketing department wants a $500,000 advertising campaign that would increase demand by 20%. But based on the solver, the factory would still produce the same amount for Classic Cruiser with or without the campaign. In this question, Rachel wants to use overtime labor to increase the plant's capacity by 25%. So in the constraints, labor hours would increase to 60,000. With this increase, the plant would be able to produce 3,250 family thrill seekers and 3,500 for Classic Cruiser. Based from question C that used overtime labor and question A that didn't, we can produce the equation of 30,600,000 minus 26,640,000, which would equal to 3,960,000. This would be the maximum amount Rachel should be willing to spend for overtime labor. The demand for Classic Cruiser is increased by 20%, which would equal to 4,200 cars, and the labor hour capacity would also increase by 25%, which would equal to 60,000 hours, which would mean that the plant needs to produce 3,000 family thrill seekers and 4,000 classic cruisers for a maximum profit of 32,400,000.
Moving on to question F, accounting for both the advertising campaign's 500,000 and the maximum labor, which is 1.6 million, you will get a total of 2.1 million to be subtracted from the answer in question E, which was 32,400,000, which once subtracted will result into 30,300,000, which is still greater than the answer of question A, which was 26,640,000. In question G, the number of profits the family thrill seekers receive has been reduced from 3,600 to 2,800, which the ending result is that the amount produced by family thrill seekers is now 1,875, and the classic cruisers are now at 3,500. In question H, the labor hours for family thrill seekers have been increased from 6 to 7.5. The end result of this is that the amount of family thrill seekers produced will be 1,500, while the cruisers are 3,500, resulting into a profit of 24,300,000. The board of directors of Automobile Alliance asked Rachel whether or not she could meet the full demand of classic cruisers. If the profit resulting from that was a decrease of less than 2 million compared to question A, she would go through meeting the full demand. So as you can see here, Classic Cruiser has met the full demand of 3,500, which has the ending profit of 25,650,000. Comparing this to question A's 26,640,000, there is less than a 2 million decrease in profits, which means Rachel should go through meeting the full demand.
In Part J, we layer together every adjustment introduced in early questions F, G, and H. First, the targeted ad campaign raises the classic cruiser demand ceiling from 3.5 to 4.2 cars. Second, authorizing overtime increases monthly capacity by 25% from 48,000 to 600,000 labor hours. Third, profit per thrill seeker falls to $2,800 and its assembly time lengthens to 7.5 hours because of the added quality checks. These changes give us the updated constraints you see on the slide. Feeding them into solver yields a clear optimal production mix of 2,120 thrill seekers and a full 4,200 cruisers. Financially, that schedule generates $28.616 million in gross profit. After subtracting the 500,000 advertising spend and 1.6 million overtime premium, the net profit is 26.516 million. The takeaway is even with the lower margin on thrill seekers and the higher assembly time, the combined strategy of advertising and overtime is still the most profitable course. We recommend Rachel proceed with both initiatives and produce the quantities shown.
In conclusion, the case utilized linear programming along with the solver function in Excel, and as mentioned again, Rachel should make the final decision to undertake both the ad campaign and implement overtime, which produces 2,120 family thrill seekers and 4,200 classic cruisers, resulting in an after-cost net profit of $26,516,000. That's all. Thank you for listening.